Hello everyone, welcome to today's class. Here we have a very simple matoliped challenge. Okay, it's a talking matoliped question. The question is easy if and only if you know what to do. Okay, we'll be given 4 to the power of n plus 2 to the power of n equal to 8 to the power of n. Then we are now asked what is the value of 4 to the power of n minus 2 to the power of n. Now, if you are not too good at what to do here, you will solve for the value of n from here. And then you're going to solve for 3 roots to this challenge here. And you substitute each of them into this equation, then you can get the value of the expression 4 to the power of n minus 2 to the power of n. But here we're going to use a very quick method. See how to solve this here now. So take our solution. So yeah, we just have to rewrite the first equation because we can express all the terms in the first equation to base 2. So if we have that, 4 can be written as 2 to the power of 2, all to the power of n, then plus our 2 to the power of n, they equal to 2 to the power of 3, or to the power of n, right? Now, according to the law of indices, it says that if you have your m to the power of ab, this is the same thing as your m to the power of your a bracket all to the power of b, and you can interchange this to give us our m to the power of your, let's take a b first, then r to the power of a. Okay. If we look into this carefully, then we can bring 2 out, push in n. Then we'll do same thing here. So if we do that, we're going to have our expression to be our 2 to the power of your n, right? R to the power of 2 there plus our 2 to the power of n. This is equals to our 2 to the power of n, r to the power of 3. Good. Yeah, if you look carefully, look at what I asked to look for. 4 to the power of n minus 2 to the power of n. So how can we get this expression from here? All we just need to do is to move this term to this side of the equation. By so doing, we're going to have this sign here, minus first. So let's keep this one here. So we're going to have 2 to the power of n on this side is equals to, here we're going to have 2 to the power of n all to the power of 3, then minus our 2 to the power of n all to the power of 2. Right. So we are getting them gradually. So how do we bring out 4 and 2 to the power of n from here? Already we have 2 to the power of n here already. So how do we now bring out this 4 to the power of n here? That's the next thing, right? So here we can rewrite this expression we have here and also rewrite this expression we have here. And so let's go ahead and rewrite this. So this is going to give us here 2 to the power of n. This is equal to, here we're having 2 to the power of n, there all close bracket to the power of 3. If we use this to open up this is going to give us 2 to the power of 3n, right? And 3n could be written as 2n plus n. All right? So from here, this is going to give us 2 to the power of our 2n plus n. Right? Then minus our 2, we do same thing here. Here it's going to give us n plus n. Because we're going to have 2n from here. All right. So how do we do? According to the law of indices, we can rewrite this expression we have in here now. So this will give us here our 2 to the power of n. This is equal to 2 to the power of 2n times our 2 to the power of n minus, here we're going to give us 2 to the power of n times 2 to the power of n. All right. So let's see what this gives us in time. Now, you discover that we're having 2 to the power of n and here 2 to the power of n. So let's factor out 2 to the power of n. So we have our 2 to the power of n equal to 2 to the power of n bracket. If we use 2 to the power of n to divide this, if we cancel out this, we are left with this. So we are now left with 2 to the power of 2n, then minus. We use 2 to the power of n to divide this. It will cancel out one of these. So we have here 2 to the power of n close bracket. Wow. What do we do next here? It is easy, right? We have 2 to the power of n here, we have 2 to the power of n here. So this, or you can say divide by 2 to the power of n. Divide everything here by 2 to the power of n. So that this leaves, this leaves. So when I have 1 is equal to 2 to the power of your 2n, then minus 2 to the power of n. Now again, look at this law. We can rewrite this as 2 to the power of 2 or to the power of n, right? So I have 1 is equals to 2 to the power of 2 or to the power of n minus 2 to the power of n. And what is 2 to the power of 2? That is 4. So we have 1 is equal to 4 to the power of n minus 2 to the power of n. So therefore, if we rearrange, bring this quantity to this side, take this one to this side. So we now have 4 to the power of n minus our 2 to the power of n equal to 1. So what does that imply? It means that our 4 to the power of n minus 2 to the power of n equal to 1. Okay, so if you look at this expression, if you had gone ahead to solve for n first, it will take you a longer way because you will go to form a third degree polynomial equation whereby you go to solve for 3 roots. Then substitute each of them into this to get the value of n. So this brings us to the end of this math challenge. If you learn something from this Turkish math question, then give the video a thumbs up. And again, you have any question with regards to this, drop it in the comment section. We are there to reply to your comments. Remember, this is Online Maths TV, and all of us here will love you dearly. Thanks for being there for Online Maths TV. Keep winning until we meet you in our next class. Bye for now.